Hello, this is lecture 19 and welcome to this lecture. In this lecture, we will be talking about how to carry out a hypothesis test. In the previous lectures, we learned how we write the hypothesis test, and a hypothesis test includes two hypotheses. One is the uh, null hypothesis that we denote it using H sub 0. And then we have the alternative hypothesis that we denote with H sub A. And there is always two decisions. One is accept H sub 0 or fail to reject. Well, this is fail to reject the null hypothesis, and then we have reject the null hypothesis. So both the conclusions, they are written with respect to the null hypothesis. Now, this is just the introduction, and we have the basic idea now what a hypothesis testing looks like. Now, how do we carry out? How do we reach to this conclusion? Because this is the ultimately we wanted to reach at this conclusion, either to accept to reject H sub 0 or fail to reject H sub 0. So there are two terms or terminologies that we need to learn here before we go to the calculations. The first one is a p-value, and then we have the so-called test statistic. Now, a test statistic is a value that we calculate from the sample, something like this one. There are different types of test statistics. One is Z. We have been learning this Z for a couple of for a while, and yeah, we call this one a test statistic. And there are other types of test statistics, and I think we will learn at least two of them or three of them in the next chapters. But anyway, for now, this is what we call the test statistic, and basically this is a standardized form of the population, the sample value, which is p hat. And p-value is a probability value that we calculate using this test statistic. And the p-value specifies how likely it is that a sample would be as or more extreme than the one observed if H sub 0 or the null hypothesis were true. For example, now we are considering a normal curve. So suppose we have here at the center, we have population parameter, let's call it P sub 0. And when we standardize the P hat, let's say the P hat is the standardized form after calculating this Z. This is the standardized form of P hat. It's somewhere in here, suppose. And now we are looking at this part, this area. Now, given the population parameter is the same with this one, if it is true, then how likely is it to find a sample which results a value something like this? Is it very is it surprising? So if it is very small, if this probability, the p-value is very small, which means if this Z is far enough from the center, then that means the probability or this area is getting smaller and smaller if we push the Z to the right or to the left, of course. But if the Z value or this test statistic is closer to the center, then the area to the right is big enough, okay? Therefore, that means this Z is not far from P sub 0, or the population, the sample proportion, which is the P hat, is not far from P sub 0, okay? because we are trying to compare p sub 0 and p sub hat, p hat. So if the distance between these two in terms of standard deviation, of course, it's not in centimeters or in inches or whatever. We measured in terms of standard deviation. So if the distance between these two in terms of standard deviation is not too far, then we would tend to accept the null hypothesis, which means there is no difference between these two. Okay, and we will see this with an example. If you hopefully you get the idea. If not, we will look at this, or we will say it using an example. Okay, now in order to take decision, by decision I mean when we compare the null hypothesis and the alternative hypothesis, what we do is we calculate the test statistic, and then using the test statistic calculated, we find the p-value. And to find this p-value, we use technology, just like what we were doing before. It's just finding the area. That's the same idea. So once you have the value, we need this value first, and that's the test statistic. So this value could be here, or it could be on the left. We will see when it becomes on the left or when it is on the right. But then after that, it's just either this area or both of them, the sum of those two areas. Okay. Therefore, once you have the test statistic, then you calculate the p-value. And what follows is you compare the p-value and alpha. Do you remember alpha? Alpha is the significance level. Okay. Alpha is the significance level. And p-value, sometimes it's called the observed significance level. So these are the values that will be compared in order to take the decision or to reach to a conclusion. And we reject the null hypothesis when p-value is small. What do we mean by small? Well, if it is smaller than alpha. So if your p-value, this p-value that you get using technology or from the table, if it is smaller than alpha, then reject. And you put if reject the null hypothesis. If p-value greater than alpha or greater than or equal to alpha, then fail to reject the null hypothesis. Okay, here we have it. Now, the steps that we need to follow in order to perform a hypothesis test or carry out a hypothesis test are described in this table. And let's look at this one by one. Now, the first thing that we need to do is you need to figure out what is the population characteristic of interest. Because, well, up to now, we have learned only the population proportion. This is what we know up to this point. But there are others coming. For example, the population mean. We will learn how to construct confidence interval about this population mean, and we will learn how to carry out a hypothesis test about this population mean. So at least, for example, now, suppose we have these two, then from the problem, from the context of the question, you have to understand and figure out what the population characteristic of interest is. Is it the mean or is it the population proportion? Okay. And of course, there are other parameters. These are just, I'm giving an example or examples. So once you have, or we figure out what the population characteristic of interest is, then you translate the research question or claim made about the population into null and alternative hypothesis. So from the claim or from the problem given, you need to figure out what your null hypothesis and alternative hypothesis are. We need to write them. So for example, if this is the population characteristic of interest, then I would write P equals to some hypothesized value P sub naught. I will use P sub naught to represent a hypothesized value, versus we have three options for the alternative hypothesis, and we depending on the claim or on the problem, we choose one of them. One is greater than P sub naught. The other possibility is less than P sub naught, and another possibility is not equals to P sub naught. So the alternative hypothesis will be one of these three, but the null hypothesis will be the same one. So you have to look at the question and understand it, and based on the claim given in the problem, you figure out whether to pick this one, or this one. And this is very, very important. You have to be very careful on this. This is I would say, the main thing when you carrying out a hypothesis, because if you pick the wrong choice out of these three, then there is like 99% chance that you will end up with a wrong answer. Okay. Well, definitely it's 100%. I would say it's not 99. It will be 100%. Yeah, because the follow-up or the calculation depends on this, not in particular the p-value. The p-value for the same problem, for the same calculation, for the same value of z, the p-value will be different depending on these three choices. Okay, even if everything is the same, just because of these three, the p-value is not the same. And if you remember, we use the p-value and alpha. We compare these two values to take decision. Okay, therefore, if the p-value is not the same, definitely our conclusion will be different because of our choice of the alternative hypothesis. Therefore, we have to be very careful in choosing our alternative hypothesis. Once we write our null and alternative hypothesis, then what we need to do is we identify the appropriate test statistic and the appropriate test. So again, we haven't learned that many test statistic and that many tests. So far, we have only one. That's the z test statistic and z test for proportion. Okay, that's what we know. But then, since there are other ones that we will be learning by now, this we should not jump this step. Okay, and then select a significance level. And again, here, this is important. If you notice, the significance level is the alpha. This is alpha. And the alpha, you have to select this alpha ahead of time, in advance, before you calculate the z value or the test statistic, or before you find your p-value. It's not after you find p-value, because, well, let's say, for example, if I'm performing, if I'm conducting a research, and well, I can, if I do that, if I choose alpha after the p-value, then I can choose an alpha that I wanted my conclusion the way I wanted it to be. For example, if I wanted to reject the null hypothesis, okay, if I wanted to reject the null hypothesis, I can pick alpha the way, in a way that it would allow me to reject the null hypothesis. But that shouldn't be the case. So you pick alpha in advance, and then you follow the other steps, and then at the end you compare this alpha with the p-value, and this p-value will come at the end. Okay, we don't know this p-value at this stage, but we identify or we select our alpha, and then we follow all the steps. At the end, we get the p-value, and then we compare it with this alpha. Then check for the conditions. Well, what are the conditions? Well, we haven't seen them yet, but if you remember, we have seen conditions for constructing confidence interval. When we learned confidence interval, how to construct confidence interval, there were two conditions. And those conditions are, one is the sample size has to be large, which means NP, we want this one to be greater than 0, greater than 10. And the second condition, well, you can interchange this one, it doesn't matter. And the second one is the sample has to be random sample, random or representative sample. Okay, so these are the two conditions that we need to check. It's the same condition with that of confidence interval. And then what we do is we find the values of the sample statistic, which means, for example, we need to find p hat, and then we calculate the test statistic, in this case the z, and then determine the p-value. Okay, because the reason why we need this one is because in the formula of z we use this p hat. It's p hat minus p sub naught over square root of p sub naught 1 minus p sub naught over n, which is okay, here is just okay, I have it in the next slide. Okay, then once you have the p-value, compare your p-value with the alpha, with the significance level, and make your decision whether to reject H naught or fail to reject H naught. And then at the end, provide a conclusion in words that is in the context and that addresses the question of interest. So you have to give conclusion in the context of the problem, because the problem, it's not going to say which one do you accept. It's not going to be this will be given and then decide which one to accept, or that's not the case, because we are talking about problems in real world. So the question, there will be a problem, and then you follow the statistical procedure, and then at the end, once you make your decision, then you have to give conclusion in the context of the problem, and you have to try to answer the question in the problem. Okay, now let's follow all those steps and look at some examples. But before that, let's see what the test statistic looks like and how we can find the p-value. So the test statistic for a large sample hypothesis test for a population proportion is given by this value. Now you may say, what is p sub naught here? Okay, because normally we use p for population proportion and p sub hat, p hat for sample proportion. Now we jump at the hypothesis here because we have already seen it, and we have it at the end, and we will see it using an example. But here, what we have here is we have the null hypothesis and the alternative hypothesis. And in the null hypothesis, it says p equals to a hypothesized value. Okay, and that hypothesized value, we are using p sub naught to represent the hypothesized value. And the alternative hypothesis will be one of the three. Okay, depending on the problem or on the claim, it will be one of the three. So this p naught that we are using in this formula is this guy. Okay, and the p hat is the one that we get from the sample. Other thing is all the same. This is the standard deviation of p hat, the denominator, and this is p hat minus p sub naught. So this is the test statistic. And when the null hypothesis is true and the sample size is large, this test statistic has a distribution that is approximately standard normal. So given this null hypothesis is true, assuming this is true, and well, the conditions NP and NP 1 minus P, both of them are greater than 10. Well, it means the size has to be large. So assuming given all both this, this test statistic will follow a normal standard normal distribution. The sample size is large enough for the distribution of the test statistic to be approximately standard normal if both NP sub naught and 1 minus P sub naught are greater than or equal to 10. Okay, so now let's come to the p-value. So this is how we find the test statistic. Now, what do we need to calculate this test statistic? Well, if we remember following those steps, first we need to we will write this null hypothesis and the alternative hypothesis, and then we calculate this p hat from the sample, and that's what we need. We need this p sub naught and p hat to calculate this one. Okay. Now, assume we have this z calculated, and then how do we find the p-value? Well, it depends. We said, as we said earlier, the p-value depends on the choice of alternative hypothesis. And there are three choices for the alternative hypothesis. And now let's look for each of the three. Let's say the alternative hypothesis is greater than, p greater than the hypothesized value, or I can write p greater than p sub naught. Suppose this is the alternative hypothesis. And for the test statistic, it doesn't change. It will be the same formula. For the z, it will be the same formula. Okay. This is the standard deviation. Now, to find the p-value calculated, the p-value is calculated as illustrated here. So this z, whatever you get out of this calculation, will be at this point. Okay. This is the point, or this is the value. This is the value. And well, this is the z curve, and the p-value will be the area to the right of z. Okay. Now you may say, why is it to the right? Why not to the left? Here, because we have this greater than. This, they are both the same. They look to the same direction. If this is greater, then you have to look at the greater area, or to the right area. How about if it is less than? If we have h sub a, p less than p sub 0. Well, again, we will calculate z using the same formula under the standard deviation of p hat. And now, since this is a less than sign, we find the z value using this one. And let's say the z value is here, and the p value will be whatever this area is to the left of that value. Okay, so this will be our p value. And the third one is a two-tailed. And here we have h sub 0, h sub a, p not equals to p sub 0. And in this case, again, remember the p-value, the z, it doesn't change again, it's the same. We follow the same formula, we use the same formula. Now we have z calculated using this formula. And we know this curve is symmetric. So let's say if you get here positive z, let's take an arbitrary value just for an example. Let's say z, using this formula, I get z equals to 1.6, for example. Okay, then there is one point here, which is 1.6, and another point here, negative 1.6. Since it's symmetric, I just put negative and on this direction, and this one will be the positive value. And the p-value will be the sum of, to the right of the positive value, the positive z value, and to the left of the negative z value. So we find these two areas and we add them up. And by the way, these two areas, they are the same. Since it's symmetric, they are the same. So once you have one of them, you just multiply by 2. So for example, this area is what? Probability of z less than, let me use here calculated just to make it different. So here z calculated here, negative z calculated. Okay, so z less than negative z calculated. Z calculated is whatever we get from this one, and z again positive z calculated. And this area is probability of z greater than z calculated. Therefore, the p-value in this case will be probability of z less than negative z calculated plus probability of z greater than z calculated. And we said these two areas are the same. These two areas are the same. So this is just probability 2 times probability of z less than negative z calculated. And this is the same with 2 times probability of 2 times probability of z greater than z calculated. So what the reason why I'm writing this one is just you don't have to find these two areas. Just find one of them and then multiply the value by 2. It will give you the p-value. So it could be, you can find either this one, which means the left side, or the right side. It doesn't matter. And then multiply it by 2. Don't forget to multiply it by 2. Okay, if you don't multiply it by 2, then it means you are testing either this one or this one, not the third choice. Okay, because for the third choice, you have areas on both sides. All right, and the conditions are here. We need the sample to be random, or it has to be a representative of the population. So this is the same. These are the same conditions with that of a confidence interval for population proportion. So these are the two conditions that we need to check. Now, suppose these are met, these two conditions are met, then this z, the test statistic, we said when the null hypothesis is true, this follows a standard normal distribution. Okay, then, well, here we have the areas. These are all these things that we have been talking about. Now let's do this example now. Or we will use this example to understand now all the things that we've been discussing. Okay. So in a study, participants were asked whether the following statement described them. When nothing is occupying my attention, the first thing I do is reach for my phone. And of the study participants in the age group of 18 to 24 years old, 77% responded yes, okay, to this question. Suppose that this group can be considered as a representative. See, this is very important because this is one of the conditions of our of the procedure of carrying out a hypothesis test. So we have it here. Suppose this is a representative sample of Canadians in this age group. And also suppose that 800 of the study participants were in this age group. Okay. All right. Now, does this sample support the claim that more than 75% of all Canadians in this age group would respond yes to the given statement? Now let's look at this. Let's go step by step now to answer this question. This is the question now. Okay, so the first thing is we need to figure out what the population of interest here is. So the claim is about proportion of Canadians aged 18 to 24 years who would say that the given statement describes them. So the population characteristic of interest is population proportion. Yes, it's a population proportion. So let's call P to be the proportion of Canadians aged 18 to 24 who would say that the given statement describes them. And the claim translates into a hypothesis of P greater than 0.75. And this claim is this one. Since it says more than 75%, then we will have P greater than 0.75. So we change the percentage to probability. Now you wanted to know if there is evidence to support this claim. So this will be the alternative hypothesis. Okay. We're trying to figure out or trying to find evidence or trying to see if there is enough evidence to support this claim. And the null hypothesis is found by replacing the inequality by an equal sign. So here we have the two hypotheses, the null hypothesis and the alternative hypothesis. So as you can see, our alternative hypothesis is one tail, which is the greater sign. And the test statistic for this one, the test will be a large sample hypothesis test. Okay. The reason why we use large sample is because when it's not large, because you remember, we need this both of them to be greater than 10. And this is why, I mean, we need to check this one. And the reason why we need this to check this one is because if this is not true, one of them is not true, or if the size is not large, then this may not follow a normal distribution. Okay, and the normal distribution is very important, and we use it in many inferential statistics or inference or in making inferences. So if it doesn't follow a normal distribution, we don't know what it follows, and we cannot conclude the way we are concluding in here. We cannot make a decision. Okay, therefore we want the sample to be large, and that's why we put this term here, large sample hypothesis test, because we are differentiating it from the small ones. Because for small sample, this doesn't apply. That's the reason. Okay. Then the test statistic is z equals to p hat minus, this is p sub naught. Remember, this is p sub naught, or p sub naught, or the hypothesized value is 0.75. So here we have the formula. And here we have alpha equals to 0.05. So the choice of alpha basically depends on the researcher. It's up to you to choose. I mean, if you are a researcher, and in this class or in this course, alpha will be given, or if it is not given, remember this, if it's not given, we use this alpha equals to 0.05. Okay, if you don't see alpha or if it's not given in the problem, use alpha equals to 0.05. And other common alpha values are, we have alpha equals to 0.1, 0.01. Yeah, so these are the three alpha levels which are very commonly used. All right. Now we need to check the conditions. Check. So the two conditions that need to be met in order for the large sample test for a population proportion to be appropriate are, let me make this one a bit large. So one is the sample size has to be large. And to check this sample size, whether it's large or not, you just check this one. N times P sub naught, N is 800, and P sub naught, the hypothesized value is 0.75. So the product is 600. And N times 1 minus P sub naught is 200. And both of them are greater than 10. Therefore, the sample is large. And how about the other condition? Well, we mentioned earlier, because it says it's a representative sample. So it's already, we are sure about it because we're assuming it's a representative sample. Therefore, both the conditions are met. And those are the requirements in order to follow this hypothesis testing procedure. Then calculate the statistic. Now what we need to do is, here we just write the test statistic. We don't perform the calculation. Okay, I just put it this way. Even you can put it this way. It's not a big deal. Here, once you write your null hypothesis and alternative hypothesis, then you can write z equals to p hat minus p sub naught over square root of p sub naught 1 minus p sub naught over n. You can either write it this way, or you can put the hypothesized value, but then you have these two remaining, and you don't need to put them at this point, to substitute them at this point, because we will do it here. So the test statistic is given by what we have up there, here, this one, and here we replace the unknowns by their values. So n is 800 and p hat is 77, because 0.77, because it says 77% they answered yes. So that's the value of p hat from the sample. Therefore, we can use calculator to perform these operations, and well, we have z equals to 1.33. Now the question is, how do I find now p-value? Well, remember, since the alternative hypothesis, the p-value basically depends on the alternative hypothesis, and the alternative hypothesis is this one. And this is what I need, the inequality. So if we draw the normal curve, our z value is 1.33. Suppose this is 1.33. And since this is greater than, this sign is greater than, then I need this area, greater than 1.33. Now the question becomes, how do we find this area then? Okay, this is our p-value. And to find this, you can, this is basically probability of z greater than 1.33, and I can use technology to find this area, and that will be right tail. Here you have the options for the three alternative hypotheses. You have the left tail. Left tail means if the alternative hypothesis, the inequality in the alternative hypothesis is less than. Right tail means if it is greater than. You see now when I change it, the shaded area becomes to the right. If I pick left, it goes to the left. If I pick both, then it's on both sides. This one is not for, you can use it to find areas, but it's not for hypothesis testing, okay? So this is what we need for now. And here you write the value of Z, and the value of Z is 1.33. And this is the area, the value of the area, 0.09176. 0.09176. When you round it, you get 0.0918. Okay. Now, what's the next step now? Now we did we did all the calculations. We found p-value. We have alpha, and the next step is we compare alpha and p-value. And well, we already chose our alpha to be 0.05. And if you compare this one and this one, which one is bigger? The p-value is bigger. Now, when p-value is big, larger than alpha, what do we say? We fail to reject H naught. Okay, we fail to reject the null hypothesis. So, because the p-value is greater than or equal to the selected significance level, you fail to reject the null hypothesis. Now, suppose our alpha was this one. Okay, suppose our alpha was 0.1. Now, which one is bigger? Well, this is larger now. If I compare these two, this is larger. So if our alpha was 0.1, then we would have rejected the null hypothesis. But now, just because of the choice of alpha, we fail to reject the null hypothesis. So you see the choice of alpha changes our conclusions. Therefore, we have to be very careful on this, performing this or carrying out this hypothesis test. And then the final step is to write the conclusion in the context of the problem. So the sample does not provide convincing evidence that more than 75% of the Canadians aged 18 to 24 think that the statement, when nothing is occupying my attention, the first thing I do is reach for my phone, describes them. So basically, there is no enough evidence to support this claim. And the claim was more than 75% Canadians, they agree with this statement. Okay, and that was the claim, and there is no enough evidence to support this. Okay, because we failed to reject the H naught, and the H naught or the null hypothesis is equals to 0.75, but the claim is more than 75%. Okay, and we don't have enough evidence to say more than 75% of them they agree with it. Okay, now for the same problem, now just to give you an idea, what if the null alternative hypothesis was not equals to 0.75? Just to give you an idea. So all the procedure is the same. I'm not going to repeat everything. And the calculation for the test statistic will be the same. So you will have this one. The only difference is on the p-value. So the p-value in this case will be on both sides. So on this side, you will have negative 1.33. And on this side, you will have positive 1.33. So the p-value for this one will be 2 times probability of z greater than 1.33. The reason why I use this one is because already we have this area. So you just multiply this by 9 is 28, I think, yes. This is the same value that we had earlier. So for the previous alternative hypothesis, we took only one area, but now we are doubling it because of the choice of our alternative hypothesis. And this becomes 6381 this area. And as you can see, this is much larger than this one. So if we fail to reject for this one, we definitely fail to reject for this one as well. Okay, even for alpha equals 0.1, this p-value is bigger than this, larger than this one. Therefore, we fail to reject the null hypothesis, even when it is a two-sided alternative hypothesis. Therefore, always, if you reject for a one-sided or one-tailed alternative hypothesis, then you definitely reject for a two-tailed alternative hypothesis. Okay, because the p-value for two-sided alternative hypothesis is always larger than the p-value of one-tailed alternative hypothesis. Okay, and well, the same thing for if you have, if this was the case, the alternative hypothesis, then well, this doesn't make sense somehow because this is too large. But anyway, once you calculate the p-value, the z-value, the test statistic, this is what you're gonna get, and your p-value will be all this area. Your p-value will be to the left of that area, which is 1.33. And as you can see, this is very large area. Therefore, definitely this area is greater than the alpha level, which is very small, 0.1 or 0.05. In our case, 0.05. And when the area, the p-value is large, we fail to reject the null hypothesis. Okay. Therefore, when you calculate the p-value or when you find the p-value, always look at your alternative hypothesis and always make sure that your alternative hypothesis, your choice, is correct. Okay. Look at the question, the problem, understand it, and figure out what your alternative hypothesis is, and then just use this alternative hypothesis to find the p-value. It will give you the direction of the p-value. Okay, so this is all about this lecture, and see you in the next lecture.